Hey guys, and welcome to this video on the C programming language. So in this video, we're going to program a hash table and insert a few values. So let's go ahead and get started here. First thing we're going to do is put a description of the program in the comments here, telling what the program is going to do. So this program creates a hash table that inserts some values. We'll do 7 values actually. That inserts 7 values using the quadratic probing method. All right, so let's go ahead and include our libraries here. So first we do the hashtag or number sign or pound sign, and then we put include stdio.h, that's our library, and we're going to also include our stdlib.h library. Okay, so now let's define the size of our hash table. So we just do the number sign, then define, and then size, and we want it to be 7. All right, so something to note here. Note that for the quadratic probing method, and I guess I'll put that here, for the quadratic probing method, the size must be a primary. So the size must be a primary number. And that's to make sure that we can insert these values on collisions, so that we can insert keys on collisions. Okay, and while we're at it, let me put another note in here. So we just continue the sentence here, and we'll say, and the hash table must be at least half empty. So these are the conditions that we need in order to use the quadratic probing method. And again, the quadratic probing method is just one of the methods to insert values into our hash tables. There are others as well, but these two conditions must be satisfied to guarantee that we can insert values into our hash table. Okay, so let's continue here. Let's go ahead and create our main function now. So integer main, and then we're going to return 0 here. And one of the things that we want to do is we want to go ahead and create our hash table. So that's nothing but an array. A hash table is just an array. So I'm going to call our variable hash table, and it's going to be of size. So our size is 7. So it's going to be able to contain 7 elements here. And so let's put in comments here. Put that we're creating the hash table, and then let's create another table. I'm going to call it empty, or another array. And the reason for this right now may not be obvious, but you'll see why later on when we start creating this function for quadratic probing, while I'm using this empty array here. All right, so let's go ahead and initialize this to be all zeros. All right, so if you're not used to the syntax here, this is basically saying make every element in the empty array to be equal to 0. So that's all it does, is it set it all equal to 0. All right, so here we're going to put initializing all elements in the array, which is called empty, to 0. Okay, now we probably need to go ahead and create this function for quadratic probing. So let's do that here. We're going to go ahead and define our function. And I'm going to make the data type an int, or the return type an integer. And let's call it quadratic probing. insert. That's pretty good. It's going to take in a hash table and an integer key value. And let's see, we're also going to take in an integer value empty. Okay, and then we need a semicolon here. So now the hash table that we're inserting isn't actually just an integer data type. It's actually a array of integers. So I'm going to put a pointer here, and then same for empty. So we put a pointer here. Okay, and key will just be an integer value. So it's going to be one of the elements in our hash table. And because the data type is an int, of course they are all the elements in this table or in this array will just be integer values. All right, so let's go ahead and now create our function down below. And because I have the data type being returned as an int here, we need to go ahead and return some integer value. I could choose 0 here. Actually, I'm going to choose -1. Yeah, that should be good there. Now let's see what we need to do, what the actual algorithm is for quadratic probing. And I'm going to write the steps here. So first, we need to get the key, and the key we're going to call k here. Okay, then 2, we need to set the counter of I, so I will be our counter variable, and we're going to set it equal to 0. And then 3, we need to compute the hash function, which is h of k. So this is going to be equal to k plus I times I, all of that modded by the size of the array. So size is the size of the array. Okay, now of course, because we are setting our I value here equal to 0, this is basically saying 0 times 0. And so of course we can simplify this even more, because k plus 0 times 0 is just k. So this is what our hash function would actually equal. And let's see, I will call the hash function index in our program. Okay, because this will be the index of our hash table, whatever this function returns here, or this equation returns, or operation, whatever you want to call it. So let's go to step 4. If the hash table at position h of k, so again, that's our index. If it is empty, then we are going to do step 4.1. We're going to insert the key, which is called k, at this position for the hash table. So hash table at position h of k, and then we're going to stop. All right, now of course, what if the hash table is not empty? So we need our else here, and if it's not empty, then we're going to do 4.3, or step 4.3, the key space at hash table position h of k is occupied, right? Obviously it's occupied, so that's something that we know. So what we need to do is we need to find the next available key space. So we need to find the next available key space. Okay, and now we're going to do step 4.4. So we're going to increment our variable I, and then we're going to do step 4.5, where we compute the new hash function, which of course again is h of k equal to k plus I times I, or I squared, modded by size. Okay. All right, so now we go to step 5, and the hash table is full. And then step 6, we stop. Okay. Ooh, that's a lot. So let's go ahead and implement this, or these steps, into our function. So first we're going to need our two variables, which are I and our hash function, which is index. And again, index is the hash function h. All right. Now let's run our loop. It's going to run from I equals 0, because now we're initializing I by 0. And it's going to run while I is less than the size of our array. So that's just size. And then I is going to increment by 1 each time. Okay. So now let's go ahead and compute our hash function. So again, our hash function is index. So we set it equal to key plus I times I. And then we mod it by the size of the array. Now, if the hash table is empty, right? So we're here at we're here checking this step here. If the hash table is empty, then we're going to insert the key value into the hash table. So how do we know if our hash table is empty? Well, we're going to use this empty array here, which is the same size as our hash table, and we're going to check to see if at that position in empty, if that is equal to 0, then we know it's empty, and then we will change that position to another number. So we change that element to another number, and that would verify that the hash table at that position has now been filled. So I'll show you what we're going to do here. So if empty at position index, and again index is our hash table, if it is equal to 0, then that means that we can insert key into our hash table. So hash table at position index equals the key. Okay, and now again we need to mark that the empty array has been or is occupied. That element at that position is occupied. So we could do that by saying empty at the same position at index is no longer going to equal 0, but we're going to change it to something else, some other value other than 0. So I'm going to just choose an arbitrary number like -1, and there we go. And what we can do now is we can return, maybe we can return index here. Yes, so let's return index. And I misspelled return, so return. Okay, there we go. And here, let's put in comments here. Mark that the position in the hash table has been taken using the empty array. Okay, and this right here is computing our hash function for probing. So I think that may be it. All right, so let's go back to our main function, which is of course right here, and let's write a for loop. So I'm going to use the variable I again, or I for this at least. So for I equals, we'll start with 0. I is going to be less than size, and then I is going to increment by 1 each time. So within here, we're going to just add, we're going to add our integer values to our hash table array. All right, so we're just going to use our function here that we created. All right, and I'm just going to get rid of I'm going to get rid of this int pointer. I'm going to get rid of this int pointer. I'm going to get rid of this int here, and then put a semicolon here. And I can do that because we have our variable name hash table here. We have our variable name empty here. Now key. We don't have a variable name key here. So what is our key going to be? Our key is going to be our I value here. All right, so I'm just going to put I for our key. And now let's take this same for loop and let's print the hash table to the console. Okay, so we're just going to do a print statement here. So printf, we'll do %d space, and then we're going to put hash table at position I, and then our semicolon. And I think that might be it. So let's give this a try. So we're going to be inserting values from 0 up to 6. So that's 0, 1, 2, 3, 4, 5, and 6. So let's see if we get that right. So I'm running it now. Okay, and we can see our hash table is 0, 1, 2, 3, 4, 5, 6, just like we expected. Let's try to change this a little bit. Let's make I equal to 1, just to see if our function here is working properly. So the first value that will be inserted is 1, and it's going to be inserted in index 1 plus 1 times 1. Well, let's see here. Let me make sure. I'm sorry. It's going to be not 1 times 1, but 0 times 0, because I equals 0 here. It initializes at 0. So it's going to be 1 plus 0 times 0 modded by size. So in position 1, we're going to insert the value 1. And let's see, once we get to 6, so we put 6 in here. We're going to put that at position 6 plus 0 times 0. So that's going to be just position 6. So let's set this to equals here so that we get 7. So now it's going to do 1 to 7. And then you're going to see that we're going to put in 7 here. And so we're going to get 7 plus 0 times 0 modded by 7. So 7 mod 7 is just 0. So at index 0, we're going to get the value 7. So let's go ahead and run this. Yep, and there we go. So at index 0, we get the value 7. At index 1, we get the value 1. And it goes on all the way up to there. Now, we can't guarantee that this will always insert values into our hash table because one of our two main conditions are not satisfied. And one of them is that the hash table must be at least half empty to guarantee insertion. So let's see if we can do an example of that. What would be a good example here? I got it. So let's do I equals 0 to 6, and here we're going to mod this by 6. So it's going to try to insert, let's see, when I gets to 6, it's going to be 0. So we're going to have a collision at index 0. So let's see what we get here. Yeah, so we have a collision here because the value 0 is already here, and it can't insert our new value, which is I mod 6, which is also 0. That last one is going to be 0. So here, okay, this is just a I guess it's a number that's already in memory. So this is really just like a C mistake here. So this isn't an actual value that we've added. And let me see if I can show that. So if I just comment this out, um, we haven't put anything into our hash table array, right? And we haven't inserted anything there. So I'm just going to print out the array and let's see the values that are in there right now. You can see we have 0, 0, 37, 0, 37, 0, and 1. So that's where we're getting that 1 from in our array. So the only way that we can guarantee that our hash table will always be able to insert values is if those first two conditions are met. And again, this goes all the way up to 6. So that very last one gets 6 minus 6, which is 0. And then we have our collision because it's already there in our array. So let me go ahead and put this back to just I and run this one more time. Okay. All right, and that's basically it, guys. I hope you really enjoyed this video on hash tables. I will leave a link in the description below to one of my other videos on another channel where I go a little bit into depth about this, like the math behind it, a little bit more of the algorithm portion of quadratic probing. So if you guys want to check that out, you sure can below. So please leave any questions and comments you have. This was actually a video that was asked of me. So, leave suggestions as well, and I might make a video of it. Uh, don't forget to subscribe, guys. And as always, thank you for watching, and I'll see you guys all in the next video.